Bismillahirrahmanirrahim. In our last class, we talked about the variables and vectors transformation. Today, we will solve some examples related to variables and vectors transformation. So, our first example is express the vector in Cartesian coordinates. The vector is given and we have to express this vector in Cartesian coordinates. So if we look at this vector is actually given in cylindrical coordinates because the coordinates of this vector are along AR, A5 and AZ. As these are the unit vectors associated with cylindrical coordinate system. So this vector is actually given in cylindrical coordinate system and we have to express this vector in Cartesian coordinates. So actually we have to transform this vector from cylindrical coordinate system into Cartesian coordinate system. Now in our last class, we had discussed that how can we convert a vector from cylindrical coordinate system into Cartesian coordinate system. It means that we have to express this vector in the form of A is equal to AX into its unit vector plus AY into its unit vector plus AZ into its unit vector. So we have to express this vector in this form. So we have to find AX, AY and AZ. We have to find AX, AY and AZ and this vector will be transformed into Cartesian coordinate system. So last क्लास में हमने ये बात डिस्कस की थी कि AX हम किस तरह निकालेंगे. So AX निकालने के लिए जो गिवन वेक्टर है एक्चुअली दिस वेक्टर जो गिवन वेक्टर है उसका हम डॉट प्रोडक्ट लेते हैं यूनिट वेक्टर AX के साथ. इसी तरह AY निकालने के लिए हम क्या करते हैं कि जो गिवन वेक्टर है उसका डॉट प्रोडक्ट हम लेते हैं AY के साथ. And the same is the case with AZ. So if we take the dot product of this vector with AX, so we will get 3 cos of phi AR dot AX minus 2R A phi dot AX plus 5 AZ dot AX, and this will actually be AX. So AX will be equal to 3 cos of phi AR dot AX minus 2R A phi dot AX plus 5 AZ dot AX. What is actually AR dot AX, A phi dot AX and AZ dot AX? So we know that AR dot AX is actually cos of phi. AR dot AX is actually cos of phi. So we will get 3 cos of phi into cos of phi. So that is cos square phi minus 2R. We know that A phi dot AX is minus sine of phi, a phi dot ax is actually minus sine of phi. So a phi dot ax, we will get minus sine of phi. So this term will become 2r sine of phi. And we know that az dot ax results in 0. So this is actually ax. So ax is equal to 3 cos square phi plus 2r sine of phi. This is actually ax component. But now if we look at this component, we have cos square phi and sine phi, and we have the r component. So हमें पता है कि r और phi, these are actually the coordinates of a cylindrical coordinate system. So we have to convert this cos square phi and r and sine phi into in terms of x, y, and z. So we have to represent these terms in terms of x, y, and z. Now if we look at these points, from this point we can find cos of phi. So cos of phi is equals to x divided by r, x divided by r, or x divided by rho. And we also know that r is equal to under root x square plus y square. So cos of phi is equal to x divided by under root x square plus y square. So cos square phi will be equal to x square divided by under root x square plus y square whole square. So this term can be cancelled out. So cos square phi will be equal to x square divided by x square plus y square. Another term was sine of phi. So sine of phi can be taken out from this term. So sine of phi is equals to y divided by r, and this will be equal to y divided by under root x square plus y square. So this was actually sine of phi. So we expressed cos square phi and sine phi in terms of x and y. So now as ax was equal to 3 cos square phi plus 2r sine phi. So it will be equal to 3 cos square phi was equal to x square divided by x square plus y square plus 2. We know that r is equal to under root x square plus y square into sine phi was equal to y divided by under root x square plus y square. So this term will be cancelled out with this term, and we will get 3 x square divided by x square plus y square plus 2y into ax. So this will be the component ax. This will be the magnitude, and ax is actually the direction. So we found the ax component. Now how can we find the ay component? So ay will be equal to this equation dot its unit vector. So we will get 3 cos of phi ar dot ay minus 2r a phi dot ay, and az dot ay results in 0, so this term will be 0. So we have to find ar dot ay and a phi dot ay. So ar dot ay, we know that it is actually sine of phi. ar dot ay, ये कल हमने find out किया था that ar dot ay is actually sine of phi. So we will get 3 cos of phi sine of phi minus 2r a phi dot ay. A phi dot ay results in cos of phi. A phi dot ay results in cos of phi. So now we have to convert cos of phi, sine of phi, r, and cos of phi into x and y terms. Actually, we have to express these angles and this r term in terms of x and y, because we have to convert this thing from cylindrical into Cartesian coordinate system, and this is actually ay. So we know that cos of phi is x divided by under root x square plus y square, and sine of phi is y divided by under root x square plus y square. So this will be whole x square plus y square. So we will get 3xy divided by x square plus y square. And we know that r is equal to under root x square plus y square, and cos of phi is equal to x divided by under root x square plus y square. So under root x square plus y square will be cancelled out, and we will get minus 2x. So this will be actually the y component. And the z component will remain the same. So that will be 5az. If we have to find az, so we will take a dot az. We will take a dot az. So we will get only this component 5az, because a r dot az results in 0, a phi dot az results in 0. So we will get only this term. And in this way, we can find ax, ay, and az. And this vector will be converted into Cartesian coordinate system. So ax dot ar dot x is cos of phi, a phi dot x is minus sine of phi. So we will get these terms, and hence the vector will be converted from cylindrical coordinate system into Cartesian coordinate system. So this is actually the conversion of vector from cylindrical coordinate system into Cartesian coordinate system. If we have to find ax, so ax will be equal to ar cos of phi minus a phi sine of phi, because ar dot ax results in cos of phi, and if a phi dot x results in minus sine of phi. Similarly, if we have to find ay, so a phi will be equal to ar sine of phi plus a phi cos of phi, because ar dot ay results in sine of phi. Similarly, a phi dot ay results in cos of phi. So we will get the ay component, and the az component will remain the same. That will be 5az, and hence the vector will be converted from cylindrical coordinate system into Cartesian coordinate system. Now we have another vector a. We have a vector a that is given in spherical coordinate system, because जो हमारे पास coordinates हैं, the coordinates are ar, a phi, a theta, and a phi. So these are actually the coordinates of a spherical coordinate system, and we have to convert this vector from spherical coordinate system into Cartesian coordinate system. It means that we have to express this vector. We have to express this vector in Cartesian coordinate. It means that we have to find ax, we have to find ay, and we have to find az. So the process is the same. अगर हमने ax फाइंड आउट करना हो तो इसी वेक्टर का डॉट प्रोडक्ट लेंगे ax के साथ. इसी तरह ay फाइंड आउट करने के लिए इसी वेक्टर का डॉट प्रोडक्ट लेंगे ay के साथ. And the same is the case with az. So first let's find ax. So ax will be equal to ar dot ax plus a phi into a phi dot ax plus not a phi, a theta into a theta dot ax plus a phi into a phi dot ax. The magnitude will be the same. A r, a theta, a phi. Actually, we have to find this thing. A r dot ax, a theta dot ax, and a phi dot ax. And we know that a r dot ax is equal to sine of theta cos of phi. A r dot ax is actually sine of theta cos of phi. In our last class, we had derived these terms that a r dot x is equal to sine of theta cos of phi. Similarly, a theta dot ax is equal to cos of theta cos of phi. So, as a r dot ax is equals to sine of theta cos of phi. Now, we have the theta angle and we have the phi angle, and we have to convert these angles from spherical coordinate system into Cartesian coordinate system. So how can we convert this thing from spherical into Cartesian, or how can we express this thing in terms of x and y? So we know that a r dot ax is actually sine theta cos phi. A theta dot ax is cos theta cos phi, and a phi dot ax is minus sine phi. Now, if we look at this thing, we can find sine theta cos phi from this equation. So sine theta cos phi will be equal to x divided by r. And we know that in spherical coordinate system, r is equal to under root x square plus y square plus z square. So a r dot ax will be equal to x divided by x square plus y square plus z square. Similarly, from this equation, sine theta sine phi can also be found out. So sine theta sine phi will be equal to y divided by r, and that will be equal to y divided by under root x square plus y square plus z square. Similarly, from this equation, cos of theta can also be found out. Now, one thing more. Remember that जब हमने साइन ऑफ फाई फाइंड आउट करना हो, सो हमें ये पता है कि सिलेंड्रिकल कोऑर्डिनेट सिस्टम में और स्फेरिकल कोऑर्डिनेट सिस्टम में जो फाई एंगल होता है दैट रिमेन्स द सेम. और सिलेंड्रिकल कोऑर्डिनेट सिस्टम में हमने ये बात डिस्कस की थी दैट y इज इक्वल्स टू r sin of phi. इसी तरह x इज इक्वल्स टू r cos of phi. So this is actually cos of theta. अगर हमने cos of phi find out करना हो तो हम वही cylindrical coordinate system वाले relations use कर सकते हैं. So cos of phi will be equal to x divided by r. But in cylindrical coordinate system, x divided by rho में कर लेता हूँ. But in cylindrical coordinate system, we know that rho is equal to under root x square plus y square. So cos of phi will be equal to x divided by under root x square plus y square, whereas sin of phi will be equal to y divided by under root x square plus y square. Now, if we have to find cos of theta, cos of phi, if we have to find cos of theta, cos of phi, so cos of theta, cos of phi cannot be found out from these relations. So हम क्या करते हैं कि इसी रिलेशन को हम sin थीटा से मल्टीप्लाई करते हैं और sin थीटा से डिवाइड करते हैं. So we will get sin theta. So we will get sin theta cos phi, and this then y divided by r, and we will get cos of theta divided by sine of theta. That is actually cotangent theta. And cotangent theta is 1 divided by tan theta. तो इस रिलेशन को हम किस तरह लिख सकते हैं? Cos of theta, cos of phi into sin theta divided by sin theta. तो इसी रिलेशन को हम किस तरह लिख सकते हैं? Sin theta cos phi divided by tan theta. Sorry, this is not cos of theta. This is actually sine of theta. Because from this relation we have sine of theta cos of phi divided by tan phi. So we know that sine of theta cos of phi is actually x divided by under root x square plus y square plus z square. And we can find tan theta, or yes, we can find or we can say that we can also write that cos of theta cos of phi will be equal to xz divided by under root x square plus y square into x square plus y square plus z square, because cos of theta is equal to z divided by r, and r is under root x square plus y square plus z square, and cos of phi is equal to y divided by rho, that is y divided by under root x square plus y square, that from cylindrical coordinate system. So in this way we can find ax, and the same is the case with ay and az. Like ay can be written as ar dot ay plus a theta dot ay plus a phi dot ay. So we have to find ar dot ay, a theta dot ay, and a phi dot ay. And ar dot ay is actually sin theta sin phi. Sin theta sin phi. So sin theta sin phi will be equal to y divided by r, and that will be equal to y divided by under root x square plus y square plus z square. Similarly, a theta dot ay is equal to cos theta sin phi. Cos theta sin phi. So we know that cos theta is equal to z divided by r, and sin phi is equal to y divided by rho, and r is equal to, so that will be equal to yz divided by under root x square plus y square into x square plus y square plus z square, because this r is from spherical coordinate system, that is equal to x square plus y square plus z square under the root, and this rho is from the cylindrical coordinate system, because phi is the same in cylindrical coordinate system as well as the spherical coordinate system. So this will be equal to under root x square plus y square. And the third is a phi dot ay, that is equal to cos of phi. And we know that cos of phi is x divided by under root x square plus y square, and hence we will find a y component, and the same is the case with az. So इसी तरह we can transform the vector from spherical coordinate system into Cartesian coordinate system. So in order to transform the vector r a variable from spherical coordinate system into cylindrical or Cartesian coordinate system, we will use these relations and we will use the same formulas. If you have any question, you can ask. Thank you.